Okay, so this is section 6.3 titled Exponential Functions, and I will follow the study guide, which begins on page 209. So we'll start with the definition. An exponential function is of the form a to the x. So y equals a to the x, where a is the base of the function. And a is any positive real number not equal to 1. Okay, so to note, the domain of an exponential function is all real numbers. And let's take a quick look at an example of what one looks like. And then we'll talk about a couple more properties of the function. So for our example, we're going to look at y equals 2 to the x. And let's make a quick xy chart. So x, 2 to the x, and we'll come up with a couple of ordered pairs. Let's plot points for -2, -1, 0, 1, and 2. Okay, so if x equals -2, we have 2 to the -2. So remember what a negative exponent means. 2 to the -2 is 1 over 2 squared, or 1/4. So that gives me the point -2, 1/4. Alright, so when x equals -1, we would have 2 to the -1, which again would be 1/2. So that gives me the point -1, 1/2. When x equals 0, we have 2 to the 0, and remember anything to the 0 is 1, so that's the point 0, 1. When x is 1, we have 2 to the 1, which is just 2, giving us the point 1, 2. And when x is 2, we would have 2 squared, or 4, which would give me the point 2, 4. So let's go ahead and plot these. Alright, so -2, 1/4, -1, we'll say that's 1, would be 1/2, 0, 1, 1, 2, and 2, 4. So this looks like this. So that's a graph of y equals 2 to the x. So if you take a look towards the bottom of the first page there, we're going to list properties of graphs of exponential functions, and we'll do this generally. So we'll do this for f of x equals a to the x, again where a can be any real number not equal to 1. And we can kind of look at what we figured out here with y equals 2 to the x to answer these questions. Alright, so first of all, the function is an increasing function. It's always rising from right to left, and that's when a is bigger than 1. So for numbers like 2 to the x, 3 to the x, 4 to the x, it'll always be an increasing function. Okay, the graph includes the points. It'll always include the points 0, 1, and 1a, whatever a is. And you can see that over here. Here is our 0, 1 point. So whenever I plug 0 in for x, since any number to the 0 power is 1, I can say that 0, 1 will always be on the graph. And likewise 1a. So again, whatever a is, in this case it was 2, 1, 2 was on the graph, because when I plug 1 in for x, that's just going to equal the base. So for this general statement a to the x, we can say we'll always have that point 1a, again whatever a is. And really knowing those 2 points is the quickest way to get a nice basic graph going once you have, the basic shape. So if I was going to graph y equals 3 to the x, I know what 2 points will be on the graph. I know that 0, 1 will be on the graph, because anytime I put 0 in for x, I will just get 1. And I know that 1, 3 will be on the graph, because when I put 1 in for x, it just equals 3. So if I plot 0, 1, and 1, 3, and I know that it's, I'm going to miss my point. It's going to look something like that. So knowing those 2 points is one way to come up with a quick sketch now that we know the basic shape. So another important thing to note is that as this comes down, it's never going to touch or cross the x-axis. So the x-axis, or that would be the line y equals 0, is a horizontal asymptote. So what that means in terms of end behavior, and those are the next 2 statements, 3 and 4 at the bottom of the study guide, as x approaches infinity. So as I look to the right, what is the graph doing? F of x is going up, so is approaching infinity. And as x approaches negative infinity, so now as I look to the left, the graph is approaching 0. So f of x is approaching 0. Okay, and again, we've already stated the domain. The domain is all real numbers. It does go to the right and to the left forever, but now that we've identified that horizontal asymptote, what is the range? The range is from 0 on up, not including 0, again because 0 is an asymptote. Okay, so if you turn to the next page, we're going to look at another example of a graph. This time we're going to choose an a value, so a base that's in between 0 and 1. So those properties that we just listed on the previous page were for numbers larger than 1. So now what if we look at fractions here in between 0 and 1? For example, let's look at 1/2 to the x. And again, if we plot those same points, what 2 points do we know for sure? We know for sure that we'll have 0, 1, because if I put 0 in for the exponent, anything to the 0 power is 1. So I know I have that point for sure. And then what other point will I also have? But 1, 1/2. So 1, 1/2 is down here. I could plot another point. We could go ahead and plot -1. What happens when x is -1? I would have so -1, we would have what? 1/2 to the -1 power, which would be, this would flip, right? This would just be 2. So -1, 2 would be on the graph. So this, okay, will look about like this. The same shape, but when a is in between 0 and 1, so that's fractions, that's like 1/2, 1/3, 1/4, you're going to have a decreasing function. So it's falling from right to left. We still include the points 0, 1, and 1a. But now our end behavior is going to change. We still have that horizontal asymptote at y equals 0, but now as x approaches infinity, so as we go to the right, the graph approaches 0. And as we look to the left, so as x approaches negative infinity, the graph is going up towards positive infinity. So domain and range are the same. That doesn't change. The domain is still all real numbers, and the range is still from 0 on up.